Section 3.3, Factor Trinomials of the form x squared plus bx plus c. So in this section, we're going to be factoring trinomials that have a leading coefficient of 1. So in front of that x squared, there's the number 1. Since we'll be factoring trinomials of the form x squared plus bx plus c, we're going to be, when we factor that trinomial, we're going to be breaking it back down or factoring it into two binomials. Okay? Now on page 180, this is the actual procedure that we're going to be following to factor the trinomials. After I discuss this some more, because this is the procedure I'm going to be following, if you want to refer back to this, it may be helpful to you. But I think after I discuss it some more, it will make more sense. If I just read this to you right now, I don't think it's going to make a lot of sense. Okay? But I do want to point out, obviously, the x squared is the first term in the trinomial. The b is the coefficient in front of the middle term. And c is the last term. Okay? Now, when we're factoring these trinomials, there's going to be two different cases. Okay? So if you look at the top of page 181, the two top scenarios show you case 1. And in both of these cases, notice we're factoring x squared plus 6x plus 8. And notice when you factor it, it's going to factor back to x plus 2 multiplied by x plus 8. So in unit 2, we multiplied x plus 2 times x plus 4 and got x squared plus 6x plus 8. And notice when we factor that, notice that c, or the 8 in this case, is positive. Whenever the last term c is positive, notice your two binomials are going to have the same signs. Notice they're both positive here. Okay? And then next door, when we factor x squared minus 6x plus 8, notice c is also positive. And notice down below, when it factors into the two binomials, the signs are also the same. So in case 1, whenever c is positive, when you factor the binomials, they're either going to be both positive or both negative. Okay? Then in case 2, if you look at case 2, notice when you look at c, or the last term of your trinomial, notice they're negative. So whenever you first look at a trinomial that you're going to factor, look at the sign that's on the c term. And if that's negative, that's going to let you know that the signs in your binomials are going to be different. In other words, one's going to be positive and one's going to be negative. So I'm on the next slides, I've added some slides because what I'm going to do is let's kind of think back to Unit 2 and think about what we did when we multiplied, for instance, x plus 2 times x plus 4 and x minus 2 times x minus 4, because I think that's going to help you more easily understand how to factor these. Okay? I think it's worth taking the time to do that. So I'm looking at one of the first cases, x plus 2 times x plus 4. And when we multiply this, we use the acronym FOIL to help us. Okay? So our f was multiplying x times x, which gave us x squared. Then we multiplied our outer, x times 4, and that gave us 4x. We multiplied our inner, 2 times x, and that gave us 2x. And then we multiplied our last, 2 times 4, and that gave me a positive 8. Now notice our outer and inner together, we combine those, and that gave us our 6x. So that's our outer and our inner combined. Our positive 8 came from our last, and our x squared came from our f. Okay? So think about that. Now, in Unit 3, I'm starting with, and I'm telling you to factor x squared plus 6x plus 8. And you know that this came from your F, this came from your L, and this came from your O and your I. And I've told you, first of all, to look at this sign. That's a positive. That means when you factor down here, when you have your two binomials, these signs down here are going to have to be the same. That means they're either going to have to both be positive down here or both be negative, and we can just wait to determine that. Now we also know, well, let's just go ahead. So we know that this times this has to be x squared. So we know x multiplied by x is x squared. We also know our L, our last, this multiplied by this has to be 8. So let's determine the possibilities it could be. Let's list our factors of 8. Well, we know 1 multiplied by 8 is 8. And we know 2 multiplied by 4 is 8. So, in order to figure out what factors to choose, we need to figure out which two will add up to our middle term 6x. So which two factors of 8 will add up to 6x? And you can see, and our signs have to be the same. So you can see that 2 plus 4 will add up to 6x. And we can check using FOIL. That's the last step in our procedure. Actually, on the top of page 180, it says check your answer using the FOIL method. Our inner, 2 times x is 2x. X times 4 is 4x. We know it needs to add up to our middle term, positive 6x. We know our signs need to be the same. In order for it to add up to positive 6x, these would both have to be positive. And obviously we knew what our answer was going to be. Okay, and then just double check using FOIL. Let's look at the next scenario of case 1. So once again, and I'm going to be kind of quick on this because I know these ones aren't, I'm just trying to help you understand how to factor these based on, undoing the FOIL that we did in Unit 2. So x times x gave us our x squared. We did our outer, x times negative 4, that was our negative 4x. Our inner, negative 2 times x, is negative 2x. Our last, negative 2 times negative 4, is positive 8. Our outer and inner together add up to negative 6x. Drop down your positive 8, that's our L. And our x squared, remember that's your F, excuse me. So now we are going to factor x squared minus 6x, positive 8. This is our F, this is our L, this is your O and your I. Notice this is positive. That means our signs down below have to be the same. Put your F in. X multiplied by x is x squared. Your L, factors of 8, 1 and 8, 2 and 4. We're looking for the two that will add up to the middle term 6x. So once again, it's the 2 and the 4. But now our inner and our outer have to add up to negative 6x instead of positive 6x. 2 times x is 2x. 4 times x is 4x. In order to add up to negative 6x, instead of them being both positive like in the previous example, in this case they'd have to be both negative. Alright, so those were both of the scenarios for case 1. I'm only going to do one of them for case 2 when the signs are different, and then we'll start practicing some different problems. Okay, so here's one of the scenarios for case 2 that you can see at the top of page 181. If we multiplied x plus 7 times x minus 5, well, if we FOILed this, x times x is x squared. There's our F. Our outer, x times negative 5 is negative 5x. Our inner, 7 times x is 7x. And our last, 7 times negative 5 is negative 35. Our outer and our inner combine. Negative 5x and 7x is positive 2x. Drop down your negative 35. and your x squared. So your x squared is your f, your negative 35 is your L. So now, unit 3, we're factoring x squared plus 2x minus 35. You recognize this is your f, and this is your L, and this is your O and your I. You look down here and you see that this is negative, so you know down below your signs have to be different. I'm just going to put DIFF for different, okay? So you draw your two sets of parentheses. You know one's going to be a plus in the middle, one's going to be a minus. You're not sure which, okay? So start with your f. You know that x multiplied by x is x squared. And now think about your L. This times this, your L times your L has to be 35. So you're considering your factors of 35. You know 1 times 35 is 35, and you know 5 times 7 is 35. Now look, glance at your middle term. Your OI has to be a 2x. So your inner and your outer have to add up to 2x. But since your signs are different, remember when your signs are different, you actually subtract. So you can see that if your signs are different, 7 and 5 will give you a sum of 2. So let's put a 7 and a 5 in. So now we're wondering, where are our signs going to go? Well, if I do my inner, 7 times x is 7x. If I do my outer, x times 5 is 5x. Now think about this. This is sometimes where students have a difficult time knowing where to place the signs. In order to get a positive 2x, ask yourself, will the 7 be positive or will the 5 be positive? Well, the 7 would have to be positive. The 5 would have to be negative. So negative 5 times x is negative 5x. Positive 7 times x is positive 7x. Double check using FOIL. Okay? Now, if it would have been a negative 2x up above right here, if the middle term OI would have been a negative 2x, then the 7 would have been negative and the 5 would have been positive. That's that second example of case 2 at the top of page 181, which I'm not going to take the time to do right now. I'm going to go ahead and move on to the next problem at the bottom of page 181. But I'll continue with that same procedure now at the top of page 180. Oh, maybe I did go ahead and add it. I'll just go ahead and do it. I'm sorry. I forgot that I didn't think I had added it. All right. Let's just go ahead and do this same one. So FOIL. F-O-I-L. This is the case 2, second scenario. Okay. So x times x is x squared. X times 5 is 5x. Negative 7 times x is negative 7x. Negative 7 times 5 is negative 35. My OI adds up to negative 2x. I drop down my negative 35. That is my L. My x squared. There's my f. So now if I were to factor this, x squared negative 2x minus 35, I recognize this is my f, this is my L, this is my O, and my I. So I put my f in place. X times x is x squared. I glance here and notice this is negative. That lets me know that down below my signs are going to be different. Okay, I've placed my f. Now I'm going to look at my L. 35. I'm considering my factors of 35. 1 and 35. Or 5 and 7. I glance at my middle term and I see there's a 2 there. And I notice that 5 and 7, my signs are going to be different anyways. That will give me a 2. Check my inner. 5 times x is 5x. 7 times x is 7x. It needs to add up to my middle term, my OI, negative 2x. In order for it to add up to negative 2, my 7 would have to be negative. My 5 would have to be positive. So that puts my positive here and my negative here. So those are the 4 possibilities that you're going to get. So now let's try some new problems. I know you're probably ready to move on. All right. But I think it was helpful to go ahead and show you the multiplication and then work backwards so that you can understand factoring a little better. Okay, so x squared plus 4x minus 45. First thing, notice this is a negative. So when we go to factor, our signs down below are going to be different. I don't mean the signs up above in it. My signs down here are going to be different. And I don't even want to write signs there. I just want to write different. Okay, so here's my F, here's my L, my O and my I have to add up to positive 4x. So I'm going to put my F in. X times x is x squared. My L is a 45, so I'm considering factors of 45. I know 1 times 45 is 45, and 5 times 9 is 45. My signs are different. So different signs, that 9 and 5 is going to give me, will add up to 4 if my signs are different. So I'll just put it, doesn't matter where you put them, we just need to make sure we get our signs right. I'll just go ahead and put my 9 here and my 5 here. 9 times x is 9x. 5 times x is 5x. In order to add up to positive 4x, my 9 would have to be positive, my 5 would have to be negative. So positive 9, negative 5. And then just double check using FOIL. X times x is x squared. I already checked my inner and outer. 9 times negative 5 is negative 45. So we get x plus 9 multiplied by x minus 5, or you could have x minus 5 times x plus 9. And I can put the other one. I won't do that on all of them though. That's a rough looking 9. Okay, let's try some more. W squared minus 15w plus 50. This is positive, so my signs will be the same. Down here, same signs. My F, L, O, I. My inner and my outer add up to negative 15w. So I have w multiplied by w is w squared. Let's go ahead and look at my factors of 50. 1 times 50 is 50. 2 times 25 is 50. 5 times 10 is 50. My signs are the same and it has to add up to negative 15w. We're looking at our middle term. 5 plus 10 is 15. 5 times w is 5w. 10 times w is 10w. In order for them to add up to negative 15, these would both have to be negative. So w minus 5 multiplied by w minus 10. Or you could have w minus 10 multiplied by w minus 5. I hope you're catching on. All right. F, L, O, I. Same signs. X times x is x squared. L, factors of 6. 1 times 6 is 6, and 2 times 3 is 6. My signs are the same. My inner and outer, it has to add up to 5x. My 2 and my 3 will give me 5. Check your inner. 2 times x is 2x. 3 times x is 3x. So they both have to be positive. X plus 2 multiplied by x plus 3. Next example, also there's a positive right here, so we will have the same signs. F, L, O, I. I'll do my F first. P times P is P squared. Then I'll look at my L, my factors of 8. 1 times 8 is 8, and 2 times 4 is 8. I'm looking for my factors that will add up to 6. 2 and 4. Check your inner. 2 times P is 2P. 4 times P is 4P. We know my signs are the same, so now we just need to determine whether they're both negative or both positive. In order to get negative 6p, they would both have to be negative because a negative plus a negative is a negative. So we get p minus 2 times p minus 4. Or you could have p minus 4 times p minus 2. All right, z squared minus 14z plus 49. Same signs. F, L, O, I. Z times z is z squared. My factors of 49. 1 times 49 is 49, and 7 times 7 is 49. I'm looking for the two that will add up to 14z. 7 and 7 will give me a 14. 7 times z is 7z. My outer, another 7 times z is 7z. In order to get a negative 14z, they're both negative. Now, since I have z minus 7 multiplied by z minus 7, I can write my answer as z minus 7 raised to the second power. So actually, I just factored a perfect square trinomial. Now, if you left your answer as z minus 7 times z minus 7, it shouldn't be wrong. All right. This one, my two binomials will have different signs. One will be positive and one will be negative. F. Then I'll do my L. Then I'll check my OI. P times P is P squared. I'm looking for my factors of 21. 1 times 21 is 21. 3 times 7. Since my signs are different, I'm looking for ones that will add up to, well, a negative 4p. So 7 and 3 has a difference of 4. 3 times p is 3p. 7 times p is 7p. In order to get a negative 4p, the 7 would have to be negative and the 3 would have to be positive. That puts the positive in front of the 3, the negative in front of the 7. So we get p plus 3 multiplied by p minus 7, or you can have p minus 7 multiplied by p plus 3. There's 4 more. All right, different signs. Y multiplied by y is y squared. My factors of 55 are 1 and 55. My pen's not writing. 1 and 55 and 5 and 11. My signs are different. It needs to add up to 6. And 11 minus 5 is 6. So when your signs are different, you're actually subtracting just to add up to that middle number. I hope you're catching on to that. So 5 and 11. 5 times y is 5y. 11 times y is 11y. In order for it to add up to 6y, what would have to be positive, the 11 or the 5? The larger it'd have to be positive. The 5 would have to be negative. Boy, it's getting sloppier and sloppier. So we get y minus 5 multiplied by y plus 11. All right, you might need to pull your calculator out to look for your factors of 136. Of course, I already did, so to make sure, so I wouldn't be holding you up too much. But you can see I have a negative there, so my signs are going to be different down below. So z times z is z squared. Now my factors of 136 1 and 136, 2 and 68, 4 and 34, and I found 8 and 17, which I realized has a difference of 9, so that will work. So you can pull your calculator out to help you if you run into problems to see what the factors of 136 are. So 8 multiplied by z is 8z. Z times 17 is 17z. We're looking for it to add up to negative 9z, which it will if the 17 is negative and the 8 is positive. So we have z plus 8 multiplied by z minus 17. All right, a couple more. All right, so not all trinomials can be factored when using only integers. So consider this trinomial, x squared minus 6x minus 8. So if I look at that, and I'm just going to, let me just see if I can put it off to the side. If you factor it the way we've been doing it, we would look at here and we'd say, okay, our signs have to be different because this is negative, right? You draw your two sets of parentheses. You know x times x is x squared. And you know your inner and your outer have to add up to negative 6x. So when you list your factors of 8, you know you have 1 and 8 and 2 and 4. And your signs have to be different. Well, if your signs are different, you're going to be subtracting. So this is either going to be, this will either give you a 7 or a negative 7. And this will either get you a 2 or a negative 2. So you're never going to get, your inner and outer will never give you a negative 6x. So no two factors of 8 will add up to 6. Okay, so because none of the pairs of factors of negative 8 has a sum of negative 6, we say the trinomial is not factorable using the integers. Okay, so we say that it's prime. Okay. All right. I believe that these are our last two. So let's try this one. Notice my signs have to be the same. F, L, O, I. So y times y is y squared. My factors of 32. 1 and 32. 2 and 16. And 4 and 8. And notice my signs are the same, so I'm adding them up. Okay, so if you add these up, 1 plus 32 is 33. 2 plus 16 is 18, and 4 plus 8 is 12. And ours needs to add up to negative 8y. So there's no two factors of 32 that's going to add up to negative 8y. So this one is prime. You cannot factor it. And the final one before the U tries, so I'll stop after this one. Same signs. B times B is B squared. I'm looking at my L, my factors of 40, 1 and 40, 2 and 20, 4 and 10, 5 and 8. So I'm looking for the two that will add up to my middle term 13. 5 and 8. 5 times b is 5b. 8 times b is 8b. To get positive 13b, they both have to be positive. Okay, so we get b plus 5 multiplied by b plus 8, or the other way around, b plus 8 multiplied by b plus 5. Okay, this concludes 3.3.